Hey guys, this is Alan here to review a little bit more for the FE. Specifically, this video will cover transfer functions. Let's start off with what a transfer function is. A transfer function describes the relationship between the input and the output in a circuit. It's important to realize that there's no such thing as a transfer function of an entire circuit. Instead, the transfer function seeks it does give a mathematical relationship between the output, any chosen output of the circuit, and a given input in the circuit. And the exact output that you're interested in and an input that you're interested in could change. I mean, you could have separate transfer functions for the same circuit. What's common to all transfer functions, though, is that you're describing the mathematical relationship between the output and the input, and how that output is affected by changes in the input. The figure shown on the next slide is a representation of an open-loop linear time-invariant transfer function where x of s is the input, and y of s is the output, and g of s is the transfer function. We just mentioned linear time-invariant transfer function. Let's talk a little bit more about what that means. A time-invariant transfer function is one that doesn't change with the passage of time. A linear time-invariant, or LTI, transfer function is one that can be expressed as a rational fraction of polynomials. The transfer function of a given system is represented by the equation g of s equals the output, y of s, divided by the input, x of s. Here we have a block diagram of a closed-loop feedback system. In a closed-loop feedback system, the output of the system is measured and compared to the desired input. And then the difference between those two values is calculated, and an electrical signal, a corresponding electrical signal, is sent back into the system, and adjustments are made so that the error between the output and the input can be minimized. The circle with the x inside it is a summing junction. So what happens here is as you can see from the plus sign and the minus sign close to that summing junction, it's taking the positive value of the desired input, x, or x of s, and it's taking the value of b. B is the output value after it has gone through the feedback loop. And after it goes through the feedback loop, it's not exactly the same as it was before, but the difference is calculated here, and then the electrical signal is sent as E from the summing junction back into the system. And that way the adjustments can be continually made. The error transfer function, as you can see here at the end of this paragraph, E of s equals the input, x of s, plus or minus h of s, y of s. And h of s, y of s is the result of the output having gone through the feedback loop, represented by h, or h of s. Alright, now let's talk about an example of a closed loop feedback system with which we're all very familiar. And before we do that, it'll make more sense if we talk about a system that is not a closed loop feedback system, and that is the open loop control system. And notice I didn't say open loop feedback system because in the open loop control system there is no feedback. Now, a good example of this is a toaster. And with a toaster you'll set your desired input either with a button or a dial of some sort, and that indicates to the toaster the degree to which you want your toast toasted, and then the toaster toasts the toast, and when it pops out, it's done. There are no adjustments that can be made. If the setting was too high and the toast is toasted more than you would like for it to be toasted, then you can't make an adjustment within the system once again. I mean, you can take it out and scrape it with a butter knife if you like, but that's no longer the system doing the work. So that's an open loop control system. In a in a closed loop feedback system, if we're using the air conditioning as an example, the desired input is expressed at the thermostat, and then the air conditioning unit will come on, and then the actual temperature of the room is measured, and that's your output. And then this actual temperature of the room is compared to the desired temperature of the room that is indicated when you set the thermostat. And then that difference, which is the error, is sent back to the air conditioning unit as an electrical signal, and it will either tell it to come back on to cool the room further, or it'll remain off as long as the error is within acceptable bounds. Yeah, and that's the closed loop feedback system. Transfer functions can get very elaborate. So this is all that we're going to cover in this video, but as you prepare for the FE, take time to look at different types of transfer functions and different block diagrams and how they can be simplified, and that'll go a long way towards helping you succeed on the FE. Good luck in your preparation, and we'll talk to you soon.